Good morning. Thanks for coming along, everyone. Now, Yaz, do you mind if you started recording, all good. So today, we are doing percentages, decimals, and fractions. We're learning how to, convert between all of these three different types of numbers. Hopefully you've done this already. So again, this is meant to be kind of revision, but I'll go through the nuts and the bolts of how to convert between them at some point as well anyway. In today's lesson, we're going to be doing these little bits and pieces. Today's format's going to follow very similarly to last week's. So I'm going to have a quick chat to Yasmin again, so you can kind of get to know us a little bit better. Then we're going to go through our puzzle solutions. We're going to talk about, instead of an interesting fact, I've got math for life today, how you're actually going to use math as you grow up and become a bit of an adult. And then we're actually going to do some teaching today about how to convert between percentages, decimal, and fractions, and do some questions in Mathspace. Then we're going to play a game. Last week, I don't know if you were here, we played this Gymkit game, and we just tried it. And there was a mode on there that I really wanted to try again. So we're going to play that again today with some different questions. And then I've got another, less of a puzzle today, more of an interesting question that I'd like you to answer. You're going to need to use some math to answer it. Now, remember, if you've got anything to say, we're keeping the chat open today. So feel free to type in the chat, or if you want to talk directly to Yasmin and I, you can just put a question in the Q&A, and then we can post the answers if we need to. So, Yaz, do you want to jump online? Show us your amazing face. All right. Hey, so I've got two questions for you today. Mm-hmm. My first question is, do you actually use maths as an adult? Have you used it outside of school?
Yes. Well, I'm studying math at uni, and I also work on content at Mathspace. So I personally use math all the time. But I have friends who are doing landscape architecture at uni, and also have a friend who's doing their builder's course, and sometimes I get to help them with maths. So even though my life turned into maths, other people who didn't expect to use it still use math all the time.
Right. So do you have friends that kind of go, hey, yes, I can't do the math. Can you do this for me?
Yes. Ask for help. Yeah.
Wow. You should start charging. I unexpectedly kind of went into the same boat of thinking like, look, even as a math teacher, I don't really use math outside of the classroom. But just the other day, I was like, hey, I want to create some planter boxes, some like raised veggie garden beds. And I had to do a whole pile of math for that. And so I was really glad. Yeah, there was another thing that I did the other day. What was it? I think I was doing like my finances and stuff, and I was just creating giant spreadsheets, tracking all my money. It was amazing.
It helps, right?
Yeah. So my second question for today is, and by the way, everyone, if you've got answers to these questions, feel free to type them in the chat as well. What is your favorite food?
Oh, man, there are so many options. I had to think, it took me a while to come up with an answer for this one. So I had to think, what food could I eat, even though I was so full that I felt like I couldn't eat anymore? And I thought, when I go to the local Italian restaurant, no matter what, no matter how much pasta I've had, I always get a creme brulee for dessert. So I love creme brulee.
Oh, there are people in the chat agreeing with us, loving food. The reason why I'm asking this question is because last week I found out about Yasmin, that she was a food junkie. So I thought, yeah, I am too. So I thought we would bring this up again. My favorite food, and by the way, it's not really a food as such, it's more like a vegetable, like it's like a thing that you can make into many things, is potato. Like I just love potato in any way, shape, or form.
You can do so many things with potato.
Absolutely. I remember as a teenager, I literally ate chips, like hot chips, every single day. It was amazing.
Sounds like my brother.
Yeah, I'm pretty sure my arteries aren't happy about that, but that's okay. Yeah. Thank you so much for chatting with us today, Yasmin.
Thank you. I'll be on the chat as well for everyone.
Thank you. Thanks for helping out. And if you just remember, keep the chat on track. Yasmin is there to kind of police it all. So if she asks you to kind of stay on track, if you don't mind doing so. All right, let's get started. Now, today, we're going to start with last week's puzzle, which was you have 16 squares in a big square, and you want to be able to draw some diagonals such that no two diagonals share a common point. And remember, a diagonal is a line from one corner to the opposite corner. So you could go up and top left to bottom right, or top right to bottom left. Either way works, doesn't really matter. And I'm just going to display some possibilities. So to be honest, I cheated and I just looked at the answer here. So I don't know how you guys went. But before I do this, do you want to type your answer, if you've got one, into the answer? What was the maximum number of diagonals that you could get in this 16 square? Now, someone's just asked how many people are in with us today. We've got 20 people with us today. All right, no one's done it. If no one's done it, I might save this to recycle this. Did anyone do this question? 123. You definitely cannot fit 123 diagonals. There aren't even 123 squares. Some of you may not have seen this because we put this at the end of the game, and we played the game that went a little bit over time. Yeah, a couple of people got it. It was definitely 10. I couldn't fit any more than 10 in here, even though I checked the answer. All right, so these are the 10 that you could get, which was 1, 2, 3, 4, 5. That was the most you could fit on the top. And then notice that any of the other squares beneath it, if you put any diagonal in there, it'll touch another line. Then you can do the same thing on the other side. And, oops, sorry, hang on, I messed up. There's one that shouldn't be there. Oh, there's a dot at the top of the screen now. And there's your 10, right? You can't really fit any more. Did anyone get a different orientation? Like, was anyone able to put their lines in, but in a different way, the same 10 lines? No? Or did everyone get exactly the same as me? Oh, right. So someone said they did it the other way around, which was on the side. Oh, right. You did it like this? Well, you could have done it this way. That's another way you could have done it. Right? Same thing. All right. So that was I thought it was a pretty easy one from last week. I've got a doozy for you this week. All right, you ready? Now let's get into the next part. So talking about using math for life, here's a question for you. What do you as students, as young people, as year 7s have more than any other adult in the world? More than me, more than Yasmin, more than your mum and dad? What do you have more of? What does you have more life mean? What, more brain space? I don't know about brain space. More love? No. You surely an adult has as much love as you. Taste buds? Okay, that's fair one. I guess assuming your taste buds die over time, sure. Video games? No, I challenge you. I probably play more video games than you do, let's be honest. Someone's kind of got it. Youngness, lifespan, that's exactly on the right track. You have way more time. You are gonna live longer than I can from now, hopefully, right? You just have way more time. Let's say the average lifespan of a human is 80. I'm about 30 now, so I've got another 50 years. What are you? You're like 13, 14. So you've got another 60 something years. You got way more time than any of us adults do. So my next question is how do you make use of time to help you earn lots of cha-ching? How does time help you earn money? Now, I wish, on a side note, after doing this presentation, I started following my own advice that I'm about to give you in here. I was just like, oh, I should have started this so much earlier. You ready? And don't do the lottery. The lottery is if you know anything about maths, you know that it is statistically really, really bad to do the lottery, right? Yes, people win, but the average person does not make any money. They definitely lose money from the lottery, right? It takes a lot of people to lose money for one person to win lots of money. So don't do the lottery. Actually, I guess make up your own mind. You can do the lottery if you want. But it is time to learn about compound interest. And this ties in very, very nicely to our percentages, decimals, and fractions work, because if you know anything about money and banks and interest rates, that's all percentages and all decimals. So we are going to be learning about compound interest through a YouTube video, and then I'm going to chat after we do the video a little bit about this. So I'm just going to switch up my screen. And hang on, let me just make sure the sound's working. Let me share the sound. Now, I'm not sure how loud this is going to be, so just be careful. This might blast your ears. All right.
Compound interest is the interest an investor earns on his original investment, plus all the interest earned on the interest that has accumulated over time. It is easier to think of compound interest as interest on interest. To understand compound interest, let's first look at simple interest, the interest earned on the original principal only. Suppose you deposit $10,000 into a high-interest savings account at a 5% simple interest rate for 3 years. The interest you earn each year is 5% times $10,000, which equals $500, for a total of $1,500 of interest at the end of year 3. $500 plus $500 plus $500. Now instead, suppose that you deposit the same $10,000 at 5% interest compounded annually. In year 1, the interest you earn is the same, $500. But in year 2, the interest you earn is 5% times $10,500, the original amount plus the interest you earned in year 1. So the second year's interest is $525. In year 3, you earn 5% interest on $11,025. $10,000 plus $500, year 1 interest, plus $525, year 2 interest, for an interest payment of $551.25. In total, you earn $1,576.25 in interest over 3 years with compounding interest versus $1,500 with simple interest, a difference of $76.25. The effect of compounding becomes especially powerful over longer time periods as the amount of earned interest becomes larger and larger.
All right, so that was a very, very quick...
Why is this pandemic good news for property?
What is this talking about? A very, very quick overview of compound interest. And I've actually got... I forgot to do this properly. I half did this and I forgot I did it. I've got a little spreadsheet for you that I'm going to show you about compound interest as well. So let me just quickly pull this up. That's what I was checking while you guys were watching. Here we go. All right, so what I've done here is I've crunched some numbers in a spreadsheet. If you want to learn how to use spreadsheets, I strongly suggest you do. Go on the internet. There's so many places that teach it to you. It is a really, really useful skill. And especially once you get out into the workforce, lots of places will want you to have these kinds of skills. So basically, spreadsheets are all about just using math to create different bits and pieces. I'm not really going to explain my working out here, but essentially I've got the time in months on the left here. I've got how much you're investing. So I'm investing $10. How much interest I'm getting, and then what's the total amount that you're actually ending up at the end of the month, at the end of each month. Now, this scenario really is okay. If you started now, right? If you started saving now every month $10, what could you end up with at the end of the year? Now, if you just saved your $10 of pocket money every week and you didn't do anything with it, at the end of a year, which is 52 weeks, you'd end up with $520, right? Now, if you chose to either save it, which is my table on the left, or you chose to invest it, which is on the right, and you chose to do that at 2% for savings, which, by the way, that's the best savings rate that I could find for all the banks at the moment. Obviously, that would change over time, but at the time that I did this research, 2% was the largest. Or potentially, if you invested in the share market, and the share market has a lot more volatility, meaning it can kind of go up and down. Sometimes you win money, sometimes you lose money, but on average, you'd get about 9% a year. So if you did that, so this one here is at 2%, this one here is at increasing at 9%, and you did this for a year, this is the kind of numbers that you'd be looking at. Now, I can already look at my working, and I know that I've made a mistake, but let's just keep this simple. This is, you're getting 2% every month, and this is, you're getting 9% every month. So by the way, this is way more than you'd ever get anywhere else, right? But at the end of the year, this number here, this is what we'd save just by putting in $10 every week for a year. If you got it at 2% every month, you'd actually earn an extra $400 by the end of the year. So you would have saved, you would have accumulated in interest almost as much as you putting in $10 every month, right? And at the end of that year, you'd end up with $918 in total. Whereas if you saved at 9% every month, so you got an extra 9% every month, you'd save your $520, but you'd actually, in interest, earn $10,000, right? And the beauty about compound interest is that as long as you start early and you allow interest to accumulate upon interest, over time, this thing just exponentially grows and it gets massive. So if you want to start saving for a car, by the time you're 18, you've got what, 5 or 6 years? You could definitely do it if you save. You know, at the moment, as people who aren't adults, you can't invest in the share market right now. But if you're super keen, you could potentially ask your parents, say, hey, can you do this for me? Just put it aside for me. They might want to do that. Here's some graphs to kind of show you what this looks like, right? So this is the blue part here is how much you are saving, right? Every single week. So at the end, the blue part represents the $520. And so if you've got 2% every month, you see this red part, that red part is your interest. So at the start, you get like almost no interest. But as time goes on, you get more and more interest, and you can see the curve, the graph start to curve up because of this red part, because of the interest. Look at that, it's going steeper and steeper and steeper. The blue part is a straight line, right? It's just going straight up. It doesn't kind of get steeper or anything, but this red part is ramping up very, very slowly. Now, if you look at this other one, right, it's more pronounced because the amount of interest you're getting is much, much greater, right? On the left, it was only 2% per month. This is 9% per month. And by the way, again, I'll say that these rates are, well, this 9% rate every month is ridiculous, right? It's usually 9% a year that the average return on share investments. But for 9% a month, which is a lot, look at how steep this gets, right? The blue part is your investment again, and you can see it's quite small and quite stable in a straight line, but the red part just ramps up super, super quick. So if you want to earn some cash, can I suggest that you definitely start thinking about how to save your money and how to invest it so that you get some good returns for it, and let it compound over a long period of time. So by the time you're 18, you are going to have a pretty substantial amount of savings. All right, so hey, people are talking about where they're from. We'd like to not do that in this chat, please. So if you want the chat to continue to stay open, please let's refrain from doing that. Otherwise, we're going to shut off the chat, okay? and listen to Yaz. Otherwise, if you keep not doing the right thing, we can kick you out as well. All right, so that's my little chat on compound interest and math for life. Start saving early and start thinking about how to get some good returns so that your savings will compound very, very quickly, right? Talk to your parents about it. They might be able to help you out. Okay, so let's go into it's teaching time. All right, so I'm gonna put my whiteboard on. Give me a second. I'm gonna share my whiteboard. All right, so can everyone see my whiteboard? Okay, now, what we want to do today is talk about how do you convert between percentages, decimals, and fractions. And you're going to need to know this for the game, all right? Now, I'm just going to write this. Percentage, oh, I don't want to be so light. I want to be darker. Percentages, I'm going to use a different color. Let's try this again. All right, percentages, decimals, and fractions. Now, these three things are interlinked, and I'm going to draw some arrows to show that there's a relationship from going from one to the other. So the arrow from P to D means how do you convert from percentage to a decimal, and the arrow from D to P represents how do you go from a decimal back to a percentage, right? And there is a way to convert. Oh, I don't like that. I'm going to, hang on. Let me change the arrow to the other way. I'm going to show you that there are only 6 things that you need to remember, okay? And these 6 things are all closely related. Once you know at least how to go one way on each of the arrows, you can pretty much go the other way pretty quickly, all right? Now, the easiest ones to do is how to go from percentage to decimal and decimal to percentage. We actually did this last week, right? So does anyone know, how do I go from a percentage to a decimal? Right? I don't want to know the answer, right? Someone's given me an example of 90% is 0.9. I want to know how. How do you go from 90% to 0.9? Like, what's the method you do to get there? Anyone? Someone says times 100. It's actually the opposite, right? It's the opposite way. To go from a percentage to a decimal, remember, you've got percentages are big numbers, decimals are small numbers, right? So to go from big percentage down to a small decimal, you actually want to divide by 100, okay? To go from a percentage to a decimal. Now, if you know how to go from percentage to a decimal, to go back the other way, it's actually it's the same. It's the same but opposite, right? How do you go from a decimal back up to a percentage? Well, instead of dividing, you multiply by 100, okay? So someone's example was, if I've got 90% as a percentage, and I wanted 90% as a percentage, and I want to change that to a decimal, all I have to do is divide that by 100. Remember that dividing by 100 just moves the decimal point to the left 2 times, right? However many however many zeros there are, that's how many times you move the decimal point. So you just move it to the left 2 times. So 90%, here's the decimal point, move it to the left 2 times, 1, 2, it goes in front of the 9, so it's 0.9, right? So that's what someone got before. And then if you want to go from a decimal back to a percentage, it's the opposite. You move the decimal point to the right 2 times, you go 1, 2, and you put in your 0 when you skip over nothing, and there's your 90% there, right? So that's the easiest one. Does anyone know how you go from a decimal to a fraction? Does anyone know how you go from a decimal to a fraction? This is actually quite in-depth, right? This is probably one of the hardest ones. Now, to go from a decimal to a fraction, what you have to do is, whatever your decimal is, okay, I'm going to use 0.9 for this one since we've got the same, just use this as an example. To go from a decimal to a fraction, you take your decimal, oh, sorry, I'm on eraser mode, give me a sec. You take your decimal And what you do is you take whatever the decimal numbers are, which is in this case 9, and you put it over whatever the smallest place value is. So in this particular one, I've got 9/10. So that means I'm going to put it over 10. And so that's a fraction, but it's not the smallest fraction. The smallest fraction, I have to make sure I can simplify that. It just so happens that I can't simplify 9 over 10, right? There are no common factors, which is going back to what we did in previous weeks, right? Looking for what numbers divide evenly into the numerator and the denominator, the top and the bottom. There are no numbers that do that. There's no common factors. So 9/10 is the smallest fraction. But if I had, say, 0.95, right? To turn that into a fraction, I take all the decimal numbers that are there, or not all the decimal numbers, all the numbers that aren't that are in here, and I put it over the smallest place value. Now, in this case, I've got 9/10, but I've also got 5/100. So this is the same as 95 over 100. And this isn't my simplest fraction, though. It is a fraction of 0.95, but my simplest fraction is going to be what goes into 95 and 100, what's a common factor. And I know that 5 goes into both, right? I know that 5 goes into both because 95 ends in a 5 and 100 ends in a 0. So I know that 5 goes into both. So I know that 5 goes into 100 20 times, right? Because 5 goes into 10 twice. So 5 goes into 120 times. How many times does 5 go into a 95? Well, 5 goes into 95 one less time than 100. So that means that 5 goes into 95 19 times, right? So my simplest fraction here is 19 out of 20. Now, is there any questions about how to go from a decimal to a fraction? Right? So the answer to go from a decimal to a fraction is put the numbers over the smallest place value. Oh my goodness, I'm going to run out of room. Right? And then you need to simplify on top of that. Now, it is a touch screen. That's just how bad my writing is. So now that so to go from a decimal to a fraction, that's probably one of the hard ones. Does anyone know how to go from a fraction to a decimal, how to go back the other way? Okay, so to go from a fraction to a decimal, let's say I've got, I don't know, let's say I've got 4/5. Right? How do you change that into a decimal? The answer to this, I'm going to wait 3 seconds. Anyone know? How do you change that into a decimal? It is 0.8, right? But to turn this into a decimal, all you have to do is actually do the division, right? Now, there's actually a couple of techniques here. This one, there's an easier way to do it than do the division. I'm going to show you the division first, and then I'm going to show you one of the quick techniques, but the quick techniques only work with certain fractions. So let me show you the one that works for any fraction, right? If I want to do this, I actually go, how many 5s fit into 4? Right? Anyone remember back into like year 5 and 6 doing this kind of division? But I know this is going to be a decimal, so I'm going to go, okay, I'm going to put a decimal point and I'm going to put some zeros in. Now, when I do this division, remember, I just go, how many 5s fit into, start from the left, the big 4. Now, 5 doesn't fit into 4. It goes 0 times. So I'm going to put a 0 above the 4. Decimal points line up, and then I combine that 4 with the next number, which is the 0, and I might say, how many 5s fit into 40? And so I do my 5s times table, 5, 10, 15, 20, 25, 30, 35, 40, goes 8 times. And because it goes evenly, I can stop. So 5 fits into 4.8 times, all right? Now, in some of the questions in the game we're about to play later, this is going to be pretty hard, and you might have to use a calculator. Okay, so just remember to pull up your calculator when we play the game next. So one way of converting from a decimal to a fraction is just to, sorry, other way around, from a fraction to a decimal, is just to do the division. Whatever that means, right? Do the division. One other way that you can do it, and this other method only works for certain fractions, is if you've got a denominator in your fraction that can multiply to 100, right? So, for example, 5 I can multiply to 100 by multiplying both sides by 20, right? By multiplying 5 by 20. So if I said 5 times 20 to get me to 100, and then remember, to keep this equal, whatever I do to the top number, I have to do bottom number, I've got to do to the top number. And so the bottom number is going to be 100. 5 times 20 is 100. Top number is 4 times 20, which is 80, right? Whoops, wrong one, right? And so that gives me a really easy fraction to convert to a decimal, because 80 out of 100, I just move the decimal point to the left 2 times, do the same thing I've always done, and that's 0.8 as well. So the other way to convert quickly without a calculator for some fractions is if it can multiply to 100, get it up to 100, and then do your thing of dividing or multiplying by 100. Dividing by 100, moving the decimal point to turn it into a decimal. Oh, is it? Thanks for letting me know. Okay. Now, so we've done how do you do from decimal to percentage to decimal. Last little piece we need to do is we need to do how do we go from a percentage to a fraction and a fraction to a percentage. Right, so percentage to a fraction is really easy. If I've got, let's have a look here, draw. If I've got 125%, okay? Remember back to when we talked about percentages yesterday, or last week, sorry. What does percent actually mean? Does anyone remember? What does percent mean? Per 100, right? Out of 100. So if I've got 125%, what that means is that I'm getting 125 for every 100. So what I can do here is simply take my percentage. Oops, I'm using the wrong color, but that's okay. And I rubbed up and divide by 100. Oh no. Take my percentage and put it out of 100, right? And that's a fraction. Now, when you want to remember, your teachers should really be expecting you to make sure your fractions are in its simplest form. Now, simplest form here just means that you cannot have any common factors in your numerator and denominator. So you've just got to simplify. How many 5s fit into 100? Well, we kind of talked about that before. That 5 fits into 120 times. How many 5s fit into 125? Well, 5 fits into 25 5 times. 5 fits into 120 times. So that means if that 5 fits 125, 25 times. So my fraction here is 25 out of 20. But I've got to check that and make sure, is that the simplest fraction I can get? And the answer is no, because 5 again fits into both. So I can simplify this again. 5 fits into 25 5 times, and 5 fits into 20 4 times. Do I have any common factors in 5 and 4? No, I'm done. That is the simplest fraction I can get with 125%. Now, it doesn't really matter if you leave it in its mix. What's it called? What's that number called? Improper fraction. It doesn't matter if you've got it as an improper fraction or a mixed fraction. So I could write it as 1 1/4 as well. Doesn't matter. But just be careful, read the question, because it should tell you whether it wants improper or mixed fraction. If it doesn't say, it doesn't matter. But the questions in the game that I've given you will tell you which one it wants, okay? So, I'm just gonna get rid of all this. Now, so if you want to convert from a percentage to a decimal, all you have to do is make it out of 100 and simplify. Oh my goodness. This something's in the way. I can't write the rest of the word. All right, so put it out of 100 and simplify. I used the wrong color. Oh well, too bad. All right, let's keep going. Last part, how do I go from a fraction to a percentage? Now, the way to go from a fraction to a percentage is actually the most foolproof way. So the way that you can do it every single time is actually to go to a decimal and then go up to a percentage, right? So if you've got, say, 3/5 and you want to go to a percentage, the easiest way is to turn it into a decimal first and then just multiply by 100 to get to your percentage. So for example, I'd go, okay, what's 3/5? 3/5, there's two ways I could do this one. So let me just show you one. Go, how many 5s fit into 3? Do the same thing. 5s fit into 3 0 times. 5 fits into 36 times, so it's 0.6. And then I turn that into a percentage by multiplying by 100, which gives me 60%, right? So 0.6 times 100 is 60%. So that's the easiest way to do it every single time for any fraction. But for particular fractions, which again, you can multiply to 100, the denominator can multiply to 100, do the same trick which I showed you before, which is make sure multiply the top and bottom to get to 100, which is times by 20 in this case, and times this side by 20 in this case. And so 5 times 20 is 100, 3 times 20 is 60, and so 60 out of 100 is just 100%, right? So either way works. Obviously, I've done easy numbers here. I definitely give you much harder numbers in the question set later, but that's how you convert between percentages, decimals, and fractions. Now, hopefully you've remembered that. I'm going to quit my little whiteboard now. Let me just share my screen again. And how much time do we have? We've got 20 minutes. I'm going to do 5 minutes of doing some questions on Mathspace, and then in the last 10 minutes, we're going to try our game. All right, so here we go. Fill in the blank to make the statement true. 67% is equivalent to 67 out of, what is it, please? Type it in the chat. 67 out of what? Gives me 67%. Yeah, that's right. Percent means out of 100. Boom. I'm going to skip ahead to some harder questions. 5/8. Write the equivalent fraction that has a denominator of 100. Okay, so how do I go from 5/8 into something out of 100? Now remember, you think, what do you have to multiply the bottom by to get to 100? And what do you multiply the top by to do the same thing, right? Have a go. So you're going to multiply by 12.5. Oh my goodness, I can't multiply 5 by 12.5. What's 12.5 times 5? Someone do the math for me. Well, 12 times 5 is 60. 5 5s are 2.5. 0.5 times 5 is 2.5. So it's 62.5, right? So this would be 62.5 out of 100. Obviously, if you couldn't do that by hand, you'd do that by, what do you call it? You do it on a calculator. And so now that I know it's out of 100, I can just write the percentage in. Times it by 100, which is 62.5%. Boom. All right, let's skip ahead. Do another one. All right, 0.16 as a percentage. Someone tell me, what is that? Oh, someone said 16%. You are right. Right, just times that by 100, move the decimal point to the right twice, and you'll skip over the 1 and the 6 to end up with 16%. Too easy. Okay, let's get to some harder ones. Where are some? Okay, to convert from a fraction or decimal to a percentage, we multiply by 100. Why do we do this? I don't know the answer to this question. Let's have a look. Let's read them. Multiplying by 100 introduces the percentage symbol while correctly changing the number's value. It could be that one. Multiplying by 100% introduces the percentage symbol without changing the number's value. It definitely changed the value. Multiplying by 100 removes the percentage. Definitely not that one. Multiplying by 100 increases the value of the number by 100 to make it a percentage. Oh, I don't know which one it is. It's either A or D. All right, people are going D. All right, I'm putting D. If it's wrong, I blame you guys. Oh, yes, it's A. It's not even A. What is this? It must be B then. Oh, hang on. What are we doing? From a fraction to or decimal to percentage? It must introduce the percentage without changing the RTA. Yeah, oh, sorry, it is that one. Oh, wow, it was B. I feel sad. All right, right, 62 out of 100 as percentage. What is that, please? This is too easy. I need harder questions. Oh, I wrote 62% into the chat. Silly me. All right, let's try it. Let's smash out these. How many minutes? How much time do we have? We got 3 minutes. Let's smash out these last 3. Oh, here we go. This is a bit harder. 117 out of 150 as a percentage. Can you please do that? What is that percentage? And I pretty much guess you'll have to use a calculator for this one. Have a go. I'm going to give you 10 seconds to bring up your calculator, another 10 seconds to do it. I'm going to bring up my calculator. Okay, let's have a look. So remember, to turn a fraction into a percentage, all I have to do is do the division and multiply by 100. Right, so I go 117, oops, where's my, yeah, there it is. 117 divided by 150, and then I times it by 100, 78%, boom. All right, crushing it. 17. No, I'm skipping this question. We got this last one wrong. No, you shouldn't skip it. You should really try it again and make sure you know what you're doing. That's exactly what I'm going to do. I don't shy away from failure. Let's get this right. All right. To convert from a percentage to a fraction or a decimal, we divide by 100. Why do we do this? All right. It's going to be similar to the other one, but the opposite. So dividing by 100% removes the percentage symbol without changing the number's value. I want the one that doesn't change the value. Is that the only one that doesn't change the value? No, the second one does well. Dividing by 100 introduces the percentage symbol. It doesn't do that. Dividing by 100% introduces the percentage symbol. It doesn't do that. Dividing by 100% decreases the value of the number by 100 to make it a percentage. No, it's going to be A. All right, put your votes in. Which one is it? A, B, C, or D? Yeah, let's go with A. Come on, crossing my fingers. Hooray! All right, here we go. This is, okay, we'll finish up on this one. You ready? Convert between percentages, decimals, and fractions here. So I'll convert the 31 out of 100 to a decimal percentage. And by the way, every time I made a test as a teacher for percentage, decimals, and fractions, this question was in my test, right? So I strongly suggest you can do questions like this, right? 31 out of 100, someone said it correctly, it's definitely 0.31. You just move the decimal point to the left twice. As a percentage, it's just 31. That's easy. All right, fraction, 1.81 as a fraction, what is it? 181 out of 100. Are you sure, Marcus? Is that the simplest fraction it can be? Does anything go into 181 and 100? Yeah, I'm pretty sure you're right. It's just tricking. And if we're not, Mathspace will tell us, right? As a percentage, what is it, please? Excellent, 181%, right? Just remember that if your number has whole numbers in it, that means that is greater than 100%. So 1 as a percentage is 100%, 2 as a percentage is 200%, 3 as a percentage is 300%. So only the decimal numbers, right, the 0.81, that's when it's smaller than 100, when you get like, 80%, 7%, that kind of stuff. All right, 5/8 as a decimal. Oh, we did something like this earlier. Did we do this exact question? As a decimal is 0.625. And then as a percentage, times that by 100, 62.5. Oh, I didn't put my percent sign in and I got it wrong. That makes me sad. All right. So we're going to finish up there and we're going to go to game time. Now, last week, Yasmin and I played. I am definitely playing again. Let me just bring it up. I forgot to prepare this. Give me a second. You are going to need to pull up a device so that you can either watch my screen and then use your device at the same time, or potentially just split your screen up. Have half your screen be this chat, have the other half of your screen be, what do you call it? The game, whatever you want to do. All right. Now, very, very recently, this Gymkit, the company or this thing, actually added a whole pile of different modes. Last week we said we wanted to try humans versus zombies. There is one called boss battle, and I want to be the boss and crush you all. But let's do humans versus zombies first. And I don't know what these other modes are. I've never tried them, never played this, but just because I said last week we're going to do humans versus zombies, we're going to do this one. And if you don't know how to play, just do your best. And then we might play this in later weeks to see if we can do this. I don't want to try Thanos or boss mode because I don't know what they are. I've tried humans versus zombies. That's why we're doing that, right? This is definitely not the Sesame Street one. This is definitely, what do you call it? This is definitely percentages, decimals, and fractions one. All right, so I'm going to start this. And stop spamming Isabella because we are definitely not doing that one. All right, so go to gymkit.com/play, and I'm going to split my screen. By the way, last week it was such a disadvantage for you guys to see my screen, and people kept blurring my screen. They kept subtracting my money. But that's okay. I'm a big guy. I can shoulder all of the stuff that you throw at me. Yaz, are you going to play today?
Yep.
Woohoo! This is going to be fun. All right, we got 10 minutes, guys. Oh no, but I've got to also put in my puzzle. Oh no. Oh. All right, let's get this going. All right, we got 15. How many people in the actual thing? We've got 20 people in the what do you call it? In the lesson at the moment. So we're waiting for a couple more people. That's okay. You can kind of start late if you want. We're going to start the game. Remember, just go to gymkit.com/play in a different browser, put in this code, and then you'll join up our game. You can join late, so it's all good. Just making sure that there's no bad names. All right, let's go. Let's go zombies. I don't know how this is going to work. I don't know why it's telling me to go find the rest of my team. All right, can you hear this music? This is dramatic. Hang on, let me share the music. Okay. You can join late, that's okay. All right, let's go. Let's go, zombies. What fraction is equivalent to 0.2? Remember, you can buy stuff as well, right? There's a little shop. 0.25. 2/8. That was tricky. Tricky. Oh, I've got money. Whoa. Whoa. Some people have already sabotaged. Upgrades. Money per question. Give me more money. In a class there are 18 boys. What percentage? Oh, this was from last week. I put some of last week's questions in here. Yeah, you may need a calculator for this, by the way, as I bring up my calculator. 18 out of 32, 56.2. What's it rounded to? Rounded to the nearest whole number, 56%. Oh. Convert 720 out of 20 into a percentage. Times it by 5, 35%. Yes. Get more stuff. What is 9/10 of the decimal? 0.9. 0.06 into a percentage. Ooh, 6%. More money, more money. What is 40 out of 50? How much time did I put on this game, by the way? I think I put 10 minutes, but I'm not sure. Oopsie daisy. 40 out of 50 is percentage. It is 80%. Oh, I didn't put the percentage sign. Ah! Convert 8% into a fraction in its simplest form. 8%. 8 out of 100, 4 out of 50, 2 out of 25. What is the decimal for 4 out of 8.5? Oh, come on, let's go. What can I buy? I'm gonna buy insurance, even though I've never bought it before. Thought it was awesome, but I'm not obviously not that awesome. What's the decimal of a third? In a jar of 100 lollies, 45 of them will... All right, surely I can buy something. Now, on a side note, in this particular game mode, I think we're meant to buy stuff to make sure the other team dies. So let me just show you, if you haven't seen it already, shops, power-ups. Ooh, open the treasure chest. What power-ups do I get? Deflector, subtractor, no, stuff that. See, look, I can sabotage the other team and get rid of 40 of their health. So humans, you just lost some health. And, oh, the humans have already been doing that to us. Zombies, we got to take more health off them. What is 35 out of 100? What fraction is 0.75? Let's go. What fraction is 0.6? What's a decimal for 3/5? 0.6. Convert 1.9 into a decimal. 0.01. Okay, surely I can buy something. What fraction is equivalent to 0.75? Convert 45 into a decimal. Oh, I am raking it in. Simplest improper. Oh my goodness, so much money. Oh yeah. Oh goodness. What's this one? 5 out of 1,000, but that's not the simplest fraction. Ooh, baby. This one. 8% to a decimal. Oh man. Streak bonus. Go. But I haven't been looking at the health. Oh, zombies, we've got less health. Oh, I'm about to crush some humans. Boom. Why does it cost me so much money? Oh, humans, they're dying. Oh, zombies, help me, please. Deduct their health. What is the decimal for 6/8? Oh, no. Quarter. I just guessed that one. Decimal for 7/8. Fractions equivalent to 0.125. Oh, baby. This one. No, it's the 8th one. What's the decimal for 3/8? This one. It's 11 out of 25. 50. Yeah. Oh, I forgot the percentage sign. Put 0.06 into a simplest fraction. 6 out of 100. 3 out of 50. See what I can buy. Are we going to die? Oh my goodness, we're going to die. Oh, I can repair. What does repair do? Give me health. Increase health by 30. Give us more health. Yeah. All right. 6.25 is a decimal. 1/10 is 0.1. Oh, guys, I need you. We need to get the humans. 2/8 is a quarter. 0.25. All right, come on. I need more money. What? $10,000. What? Time, by the way. Okay, we got to finish up in like a minute. Right, I'm going to end the game in a minute. Can we please just spam them and no more saving yourselves. Death. Death to humans. Stop taking me out of this page. Oh, I don't have enough money. I need more questions. 37, 63. 5, 7, 8. 2 out of 10 as a percentage. All right, come on. Oh, zombies were about to die. Get them, guys. Get them. Get them. 90%. Oh, I didn't read the question properly. That's 2. 1.25. What? I didn't read the question again. Convert 720 into a decimal. 35. Oh, it's 0.35. I'm making mistakes. This one. Oh, zombies, we're about to lose. Don't do it, zombies. Oh, I fluked that. 3/4. Save us, save us. That's a percentage. 1.9% into a simplest fraction. Whoa. When is this one? Oh, it's out of 2001. What's the decimal? I wrote most of these questions too. This is 3/8. Oh, goodness. Save. Save. Oh. Oh, I've got no more money. I need more questions. Oh, zombies. In a class 6 shooters, there are 10 boys. I need my calculator. Where's my calculator? Oh. All right. Let's see what the results were. That was fun. I like that. Good job, humans. Good game. Yaz, were you on my team and we lost?
Yep.
No.
I don't know how to get money.
Oh, you got to buy the power-ups. Anyway, all right, we got to get going because we're going to go do the puzzle. Hope you guys had fun with that. All right, we got a minute, less than a minute left to do the puzzle. All right, so this is less of a puzzle and more of like a little bit of a question or a project. My question to you for this week is: which country is the most athletic country in the world? And you can't just tell me, oh, it's this country. You have to provide some sort of evidence or justification about your answer to this question. All right. Now, obviously, you don't have to do this. This is just something that if you want to, obviously have a little bit more fun, do a little bit more maths. And the area that we're diving into for this particular question is statistics. You need to come up with a whole pile of data or information. Think about, I should go to the next slide. Think about what information you need to answer this question. Do some maths on it. So you might want to use spreadsheets. You may want to use mean, median, and modes. Some of the things that you would have learned from your maths last year. And then think about how you want to write this answer up and justify it so that basically, do you want to do a report? Do you want to do a presentation? It could just be a one-pager. Whatever it is, I don't really care. But think about all of these kinds of things, right? What information do you need? What math are you going to do? How are you going to present this information? Now, I've done a little bit of work for you already, and I've gone and looked up the 2016 Rio Olympics medal tally, right? And is this the best way to measure athleticism? I don't know. It's one way, I guess. Might want to think of another way. I just thought I'd point you in our direction. It doesn't have to be this direction. You can answer that question however you want to. So what's really interesting is when I looked at this medal tally, United States crushes everyone else. We, as Australia, just snuck in 10th place with 29 medals. But medals aren't everything, are they? There's maybe some other factors you may want to consider about what makes a country athletic or not. So that's a really, really open-ended question. I thought I'd give you a really hard one. Not a hard one, but something that's going to take a little bit more time compared to the last one I gave you. Before I leave, though, I want to make sure that if there are any questions, that I answer them before we go. So if you want to stick around and ask questions about this particular puzzle or task or question, please feel free to type it in the QA or the chat. Okay, someone's put in, they've just ripped something off the internet to say that Russia was the most athletically talented country. Sure, you can say that, but I want you to tell me why. I don't want you to say some site that I Googled told me. I want you to show me some math that shows me that they're the most athletic. Okay? Any questions? Now, what I will do is on the website, on the Mathspace Academy website, I'm going to post up the medal tally for all of the for the 2016 Olympics. I'm going to put up that medal tally as a spreadsheet, and that will actually have all of the countries that ever got a medal. So I've only just put up the top 10 on this slideshow, but that'll have like, I can't remember how many countries there were, like maybe 50 countries or something that got a medal in the last Olympics. So any last questions? Yeah, you can leave whenever you want, no problem. Thanks for joining us. Any questions? All right, so this slideshow and the spreadsheet is going to be posted up on the Mathspace Academy website. The recording for this will also be posted up. Probably just wait a day or two. The last thing that I really want to ask your help on is that after each of these sessions, a little survey goes out. And I would really, really love it if you could give me some feedback on how I'm going, just so that, again, I can improve this as much as possible and make sure that you guys are enjoying what I'm doing. So fill out the survey, have a crack at this question if you're interested. And if you want to, what I might do is give you a way what I'm going to do is I'm going to put my email address. This is very, very risky. I'm going to give you my email address in the chat. And then if you want to post your answer to me, email your answer to me in whatever shape or form you want. So if you want to do a report, or if you want to do a slideshow, whatever it is, feel free to email that through to me. arfu@mathspace.com.au. Yeah, please don't spam me or I'll have to block you. And yeah, thanks so much for coming along today, guys. I hope you had fun, and hopefully I'll see you next week. All right, I'll stay on the chat online for a little bit longer if you want to chat for 5 minutes or so, ask any questions. Otherwise, I'll see you later. Have a good day. Bye.